Alright, this is Mr. Gillum, and today we're going to learn our first proving triangles congruent postulate, and it's called the side-side-side postulate. And so I like that keyword there, prove, so we're going to do some more proofs here with these, but I think you'll like them. They're not too bad. Basically what the side-side-side postulate says is that if three sides of one triangle are congruent to three sides of another, then the triangles are congruent. That means there was no transformation, no stretch, no compress. We learned about the relationship between the angles and the sides of triangles. Across from the smallest angle is the smallest side. Across from the biggest angle is the biggest side. And basically what the side-side-side postulate says is instead of having to prove that all the sides are equal or congruent and all the angles are congruent, it says if it's satisfactory just to have all the sides congruent. That guarantees that the angles must also be congruent. Okay, and so it kind of makes sense because if we had these three segment lengths, there's only one way we could make a triangle out of them. If we had these three different lengths, if I move this angle open just a little bit farther, then I won't connect here at this vertex. If I move this angle open a little farther and move this guy to the left, if I move this guy out just a little bit, he no longer will connect to this other segment. So the angles must be congruent if all of the sides are equal, and it makes a triangle. Okay, so it's called the side-side-side postulate. All right, so let's just go right into it here and write a little proof. And our proofs will be a little easier today because now we know this side-side-side postulate that says instead of having to prove all the sides and the angles congruent with the CP-CTC, what we can do is as long as we have the three segments that are congruent, then we can use a side-side-side postulate to say that they are in fact congruent triangles. So the first thing I'm going to do is I'm going to say all this stuff right here. Now, Mr. Gillen doesn't have the best handwriting, so I'm just going to bubble this in, but you can fill it in on your paper. I'll give you a second to do that. We're going to write all this given information in there. Okay, it says triangle QRS is isosceles with QR being congruent to SR, so I'm going to label the diagram. You go ahead and write the given information in. QR is congruent to SR, and it says RT bisects QS at point T. RT bisects QS at point T. So eventually in our proof it's going to say we're going to have to put these little congruent lines right here. Okay, so I'm going to write them on my diagram, but we're not to that part yet. The original reason is the given. All that information is given, and we know that we have one of the pairs of segments congruent already. Okay, so like I said in here, I'm writing triangle QRS dot dot dot, all the given information. All right, the second segment that I already kind of marked on here, QT must be congruent to TS. Or I should say, you know, we should really put the letters in order. We'll say it's congruent to ST. All right. QT is congruent to ST because we know that this line bisects this segment. So we're going to say the definition of segment bisector. All right. So now we have the original congruent segments and now my second set of congruent sides. And then finally, because these two triangles share a side, we know that RT must be congruent to RT. All right, and that's just a reflexive property. They share a side. They share the same exact side. RT is equal to itself, or it's congruent to itself. And then finally, since we have our three congruencies, yesterday what we had to do is we had to find out that make sure that all the angles were equal as well. Today we don't have to do that because now that we have all three sides congruent, we know through the side-side-side postulate that triangle QRT is congruent to triangle SRT. And that is through the side-side-side postulate. Alright, so new proofs today. With this postulate, like I said, we don't have to prove all the angles, we just have to prove that all three sides are congruent. And so We'll have some definitions, and we'll have some reflexive property, things like that, but also try to keep in mind that the emphasis on the side postulate as well. Constructing a congruent triangle. Now I have these steps listed here, and I'm not really sure how good diagrams really are as far as actually reading them and understanding them. You know, after all, if we could all just read the book and understand the book, there would be no need for teachers. So let's just take a look here. What it says is we want to construct the same triangle again using the side postulate. And so we're going to actually be doing constructions with the side, the side angle side, different types. So there are specific different types of constructions that I want you to learn how to do. And specifically the side happens like this. Basically I start with just a line and a point, and I'm going to put my point right here, and I'm going to draw my arc. I'm going to measure how far it is from A to C. I'm going to open my compass that far. I'm going to put my point on the point X. I'm going to make an arc. Okay, so this distance represents the point AC, or the distance of AC. Then I'm going to open my compass from A to B. Find that distance. I'm going to put my point here again. I'm going to make another arc right there. And then finally, I'm going to open my compass from C to B. I'm going to put my pointy end here and make my arc right here. And then finally, where they intersect, I can connect point X, point Y, and point Z and make a congruent triangle that is of equal angles and equal lengths, or congruent angles and congruent lengths. So just for your viewing pleasure here, I do have this little video that I found on the internet, and I'll try to explain it as he's going along just the same way. It's only 3 minutes long, so it's not that bad. What he's going to do is he's going to take his compass, and he already started out with his line already. You can see his line's already there. And he's just going to open it the distance that he wants one of his sides to be. Okay, so these represent each side length of the triangle. So once he knows his distance that he's looking for, he puts the pointy end on his initial point, and he makes an arc that crosses the segment later. Okay, and this is what you want to start with. You just want to start with a straight line and a point, so you know what you're doing. Okay, so we have this initial length, and he's representing this length in green of the first side of the triangle right here. This is the exact same segment length from here to here as it is from here to here. Now I'm going to open my compass from the red segment length just to see how far it is right there. And I'm going to go ahead and bring my compass down, and I'm going to put my pointy end on the same point. It doesn't matter which one I put it on. I just need to make a nice arc. Whatever the remaining point is that I haven't used will be for my blue segment. So I put my pointy end here, and I'm just drawing the red line, the arc of the red line. Okay, and what I'm going to actually do is I'm just going to measure the blue segment length now. And I'm going to put the point on the end of the blue segment, and on the end of the blue segment right there. And now I'm going to put my pointy end instead of right here again. If I put my pointy end here, it will never cross. This is going to be the problem. So what I'm going to do is I'm going to put my pointy end on the other side here and make my arc, and where they intersect shall be the vertex of my final piece of my triangle. So as you can see, I'm going to do a little arc, cha-ching, right there, and I have a nice intersecting. I have the green length, the red length from here, any of the points on this line right here, this arc right here, and the blue length, any of these points on this arc from point 2. So now where they intersect is where I'm going to connect my 3 vertices. I'm going to use a straight edge, of course. There's the red distance, and finally the blue distance right there. And as you can see, I now have a triangle constructed from the measures of these 3 sides. Okay, so that's it for today. We're just doing little basic proofs, simpler proofs than before, and we'll learn about the side postulate. Now tomorrow what we're going to do is we're actually going to watch some notes in class, and so everyone can kind of go at their own pace, and then we're going to do some practice over a break, and then we're going to come back and practice some more when we get back on Monday, because we're going to learn the side angle side postulate tomorrow. So that's it for today.